Hello and welcome to this series of lectures on Ztransform. In the previous lecture, we have seen what is the Ztransform, what is meant by ROC. Basically, Ztransform is a power series equation, and it makes sense when the power series converges to a finite value. So, the concept of ROC is that it confines x of z to a finite value. So in the region where x of z converges is called as the ROC of that Z transform. So region of convergence is a very important concept related to Z transform, and we have seen that the Z transform is to be specified with the ROC. So whenever we are specifying the Z transform of any signal, we have to specify the ROC, that is the region of convergence. The meaning of convergence means to attain a finite value. Okay, so whenever where x of z attains a finite value, that is called as the ROC of that Z transform. Now in this series, in this lecture, we will see about how to compute the Z transform of a signal which is of infinite duration. Now in the previous lecture, if you note that we had seen the Z transform, we had computed the Z transform of the sequences, maybe a single sided sequence which is left sided or right sided or double sided. Okay, that means it means causal, anti-causal or non-causal. We have seen that the signal were of finite duration, that is the number of samples in the sequence were finite. So in this case, there are 1 2 3 4 5 samples, right? Similarly, if you see here in the second numerical, there are only 5 samples, and here in the third numerical there are 1 2 3 4 5 6 7 8 9 samples. Okay, now how to compute the Z transform of a signal when the signal is of infinite duration? Okay, so when the signal is of infinite duration, for example, we are given a signal x of n is equal to a raised to n u of n. Now we remember that u of n is a signal which exists from n equal to 0 to infinity. So this signal x of n has values from 0 to infinity. Now this is the infinite duration sequence. Okay, so a raised to n is an exponential sequence multiplied by u of n. So a raised to n is a decaying exponential, maybe decaying or growing depending upon the value of a. So we need not bother about it because a value is not given. So it is simply an exponential sequence, and since it is multiplied by u of n and u of n exists from 0 to infinity, so this sequence also exists from 0 to infinity. Okay, so now we have to find out the Z transform of such signal. So we apply the equation of Z transform. So x of z, the x of z equation is given like this. Okay, so this is a very fundamental equation. We have to apply this equation for any Z transform, maybe it finite duration or infinite duration. So we substitute the value of x of n in this equation. Now if you see this equation now, okay, so this equation, in this equation it is u of n, and u of n exists only from 0 to infinity. The range of u of n is from 0 to infinity. Okay, so that means what, this minus infinity to 0, it will become 0. Okay, so minus infinity to 0, since u of n is not present, this multiplication will be 0, hence the limit of this x of z will now change from n equal to 0 to infinity. Okay, this is n equal to 0 to infinity. So now we modify this equation. This equation is modified like this. Okay, so x of z is equal to summation n equal to 0 to infinity a raised to n z raised to minus n. Okay, because we have not written here u of n because the value of u of n from 0 to infinity is 1, and u of n is 0 for n less than 0. It is not present for negative values. Okay, so this equation gets modified like this. Now there is a fundamental summation equation. What is that fundamental summation equation? Summation of n equal to 0. Okay, summation of n equal to 0 to infinity. Okay, summation of n equal to 0 to infinity a raised to n, a raised to n is given by the equation 1 upon 1 minus a. This is a fundamental equation, but this equation is with a condition. What is that condition? This value of a, that is mod of a, mod of a should be less than 1. Okay, this is valid only when mod of a is less than 1. Okay, so we apply this formula here for this summation. Okay, now if you apply, if you fit this formula here, we will get that It is summation n equal to 0 to infinity a raised to n. So here now our a raised to n will become, a into z, okay, a into z raised to minus 1, a into z raised to minus 1 raised to n. Okay, so this is our a z raised to minus 1. This is our a here. So it is not necessary that we have to write a here. If you write b also, it will be 1 upon b. If you write c here, it will be 1 upon c. If you write d here, it will be 1 upon d. So that doesn't mean, so don't confuse that this is a, so this is this a and this a is similar. Okay, it can be anything. So a is a variable. Here we have got a z raised to minus 1. Okay, so our answer will be 1 upon 1 minus a. So this here 1 upon 1 minus a here is what? A z raised to minus 1. So this is a into z raised to minus 1. So 1 upon 1 minus a z raised to minus 1. So this is the answer. Okay, so this is the Z transform, simple. Okay, we have directly applied the formula here. So the formula gives us this value. Now we have seen the condition. Now we have to find out the region of convergence for this. Okay, so in this case we have seen that we have applied this condition, mod of a is less than 1. So mod of a is less than 1 means what? Mod of a, here a is our value of a is a into z raised to minus 1 should be less than 1. Now if you rearrange these terms, we will get mod of z should be greater than mod of a, because if you take the negative this side, it is 1 upon z. So this z will go this side. Mod of a is less than z, that means z mod of z is greater than a. So after rearranging, we'll get this. So this is the condition for ROC. So now what is that condition? Like if we plot the z plane, so z plane is always plotted like this. On the x-axis we have real part of z. Okay, on the x-axis we have the real part of z, and on the y-axis we have the imaginary part of z. Okay, on the y-axis we always have the imaginary part of z. Okay, so this is called as the z plane. So real of z, imaginary of z, and now our ROC is mod of z greater than a. Suppose this is a, so there is one pole at a. Okay, so our ROC is the region where z value should be greater than a. So all this region beyond a, okay, all this region beyond a, this is the shaded portion. Okay, all this region beyond a, so beyond a, whatever the region is there, that will form our ROC, entire z plane. Okay, only in this circle, which is z equal to a, radius z equal to a, there will be no shaded region. Other than that, there will be complete region which is called as the ROC of z, ROC of this x of z. Okay, and here for just for our convenience, we draw a unit circle. So this is 1. Okay, so this is 1 now. So at 1 we draw a circle which is called as the unit circle. The significance of unit circle we will come to know when we see the concepts of stability and causality and so on. But it is a normal practice that whenever we draw the region of convergence, we also draw the unit circle in that ROC. Okay, so now in this case, the ROC includes the unit circle. After looking at this diagram, we understand that in this case, the ROC includes the unit circle. This is the conclusion. Okay, so this is how we solve the numerical on the Z transform for infinite duration sequence. Okay, let me summarize this numerical. Okay, so whenever a signal is given, first we have to see whether it is a finite duration sequence or an infinite duration sequence. Now here in this case it is an infinite duration sequence, but whether it be finite or infinite, we apply the same formula. So we use the formula of x of z. X of z is equal to summation n equal to minus infinity to infinity x of n z raised to minus n. Okay, now we put the value of x of n into this equation. Now we observe that this equation is multiplied by u of n. So our limits will change from 0 to infinity because u of n exists only for positive values of n. Now how to solve the summation? So summation is if we have the formula, summation n equal to 0 to infinity a raised to n is given by 1 upon n. So this a can be anything. Huh? This a can be anything. Here in this case our a is a z raised to minus 1 raised to n. So this is all. So this is simply this equation you can also write x raised to n is equal to 1 upon x is equal to 1 upon 1 minus x. So that is not the problem. You can write this same equation as mod of uh, summation n equal to 0 to infinity x raised to n is equal to 1 upon x. So our x is a z raised to minus 1. So we get this equation 1 upon 1.